Let's try to solve some LeetCode today. So today we have this LeetCode 74 problem, that is search a 2D matrix. So basically you are given an m into n integer matrix with the following two properties. Each row is sorted in non-decreasing order, that means ascending order, and the first integer of each row is greater than the last integer of the previous row. Okay. Given an integer target, return true if the target is in the matrix or false otherwise. Also, we have a condition, that is we must write a solution of order of log into m into n. Okay, so basically what we have is that the question is saying that we will have a matrix and each row is actually sorted in ascending order. So we can see it very clearly, 1, 3, 5 and 7. And the next condition says that the first integer of any row will be greater than the last integer of any previous row. So 1, 3, 5, 7, then 10, 11, 16, 20, then 23, 30, 34 and 60. So this is the kind of order we have in the array. So this is the order that we have in the matrix, and now we have to figure out whether a given number exists in this matrix or not. Okay, simple. Now there is one way of doing it, that is we can traverse through each and every element from 1 to 60. So we will go for each and every element and we will check if that given element is same as the one we are traversing right now. And if that is true, we can simply return true. But the issue is that the question asks us to write a solution of a logarithmic m into n. And if we simply traverse through all the elements in the matrix, what we are creating is we are creating a solution of order of n, or basically order of m into n, not log m into n, because we will end up traversing through all the elements in the matrix at least once. So yeah, that is a solution, but it's not the most optimal solution, right? So we have to go even better. We have to figure out if there is even a better solution to this. And since they are saying that there is some logarithmic m into n solution, we can guess, okay, we can make a guess that yes, maybe we can use binary search here. Binary search is something that we usually use to find elements. The question is also saying that we want something in logarithmic time complexity, so we probably can use binary search. But the question is, how do we use binary search on this? Because this is not a simple array, it's not a one-dimensional array, it's a two-dimensional matrix, and we have till now only used binary search on one-dimensional arrays. So here we have this 2D matrix, the one from the example, and just look at it. Okay, if we just look at it, we will realize that all the numbers are in ascending order: 1, 3, 5, 7, then 10, 11, 16, 20, 23, 30, 34, 60, right? If we can somehow remove these, okay, these brackets, if we just somehow remove these, then this entire 2D matrix will simply become a 1D matrix with ascending order. And we know how to apply binary search on a simple array, right? The only issue that we are facing are these brackets that separates these numbers into different groups. If we can somehow figure out a way to bypass these matrices, then we will simply have a one-dimensional array. So how do we do that, right? So usually if we want to access something from the 2D matrix, what we do is we give the row number and the column number, right? Column number. And that way we are able to access any element from this matrix. What if I only give one single number and try to access some element from this instead of row and column? Well, I will have to figure out a way to turn this one single number into a row number and column number group, correct, into this. If I can just make a single number turn into these two, then I will be able to give a single number in the binary search and then just turn that number into the row and column number and access the elements from the matrix and make a decision there. So right now the indices are 0, 1, 2, 3, 4, 11. So if I just think of it as a single array or as a one-dimensional array, the indices will be something like this. Now I would like to map this index, okay, map this 5 with this row is equals to 1, column is equals to 1. If I can map this into this thing, then I will be able to access 11, right? So how will I be able to map it? That is the question. Is there some mathematical way of doing it? Well, we can see that we have a group of 4. The entire one-dimensional array that we are thinking of right now is basically divided into groups of 4, correct? And why groups of 4? Because in the example, we can see that we have number of columns as 1, 2, 3, and 4. We have 4 number of columns, so the entire data in the matrix is divided into 4 groups, as you can see here. one bracket here, one bracket here. So let us take 5 and try to make row 1 and column 1 through it. So since the entire data is divided into 4 groups, what if I divide this by 4? So 4 multiplied by 1 is equals to 4, and we have a remainder of 1. So I can say that this will be a row number. Okay, why will it be a row number? Because once we divide 5 by 4, what we are doing is we are taking away this entire thing. This entire set is being taken away from the consideration because we have already crossed 4. Okay, once we cross 4, then only we reach 5. That's how the division works. Now we have this remainder 1, and we can see the remainder is simply the column number, because once we have crossed 4 one time, okay, 4 multiplied by 1 means we have crossed 4 elements. So it means we have crossed one group. Okay, and once we have crossed one group, we minus 4 from 5, and whatever remains is basically the number of elements that we have left after crossing the groups. We have 1 here, and that is because basically we are starting from 0. That is why we have 1, otherwise it would have been 2, something like that. Also, I mean, the index would simply become 6 at this point, but since we are starting from 0, we can take it as 1. So 0 index for 10, 1 index for 11. So I can say that this is the column index and this is the row index. Let's try to verify it for other indices also. Suppose we have this 9. I want to access 30, right? So I want to turn 9 into row and column. I will simply divide it by 4. So 4 multiplied by 2 is equals to 8. And then we have 1 as a remainder. So 2 means we have crossed 2 groups of 4 elements. Okay. So we have one group of 4 element here. Then we have one group of 4 element here. Let me just change the color. One group is here. Okay. Then one group is here. Okay. We have two groups of 4 elements. And then we have a few elements left, that is the remainder. So here remainder, and we have one element left. Well, it means that we have 0 comma 1 element left. Okay, so we have 0 here, 1 here. Now if I take 11 as the number, the same thing should happen again, right? 11 divided by 4, 4 and 4 multiplied by 2, 8, then 9, 10, 11. So it's a 3 remainder, right? So it means I have crossed two groups of 4 elements. So I have crossed this group, and then I have what? I have 3 as a remainder. So 3 as a remainder means 0, 1, 2, and 3. These are the elements are left. So I can see that the index number 0, 1, 2, 3 is, this is a 0, this is 1, 2, and 3. So I can say that this is the column number that we are trying to access. So I can access this number 60 by saying that matrix 2 and 3. Okay, so row is 2, column is 3. So I can say that, what, my single array 11 is equals to matrix this, correct? I can just convert it. So what I can do now is I can simply use binary search. Right now we have how many elements? We have around 12 elements. We are starting from 0, so we have around 12 elements, right? So basically, number of elements is equals to 12. Okay. Now I can start with binary search, right? I can simply go ahead and figure out mid. Mid is equals to like n by 2. And at this point, the mid is actually this index. Okay. One of these indexes, 6 or 7 or something like that. It's not a row or column. So I will figure out row and column from mid by dividing it by 4, dividing it by 4, comma, the modulo or the remainder by 4. So I will figure out the row and column, and then I will simply check. Now, if the current element, that is matrix row, comma, row column, if it is greater than target, what we will do is we will simply do L, that is left pointer is equals to mid minus 1. Otherwise else, oh sorry, is going to be R pointer, and L, otherwise L will be mid plus 1, right? And yes, we will have, L pointer starting with 0, R pointer starting with n minus 1. So this should be like L plus R divided by 2, right? So this is how we can actually solve it. The main thing was to basically take one single number and turn it into row and column, and then we can simply use the normal binary search on this problem to solve it. Here you can see I have already written the code. First of all, I'm taking one L pointer, that is left pointer, then we have right pointer. So we can see that the number of elements will be the number of rows into the number of columns here. Okay, minus 1. Okay, so this is representing m number of rows, this is representing the total number of columns. We are multiplying them and then we are minusing 1 because it's a zero base index. Okay, and then we have the calls. I'm basically storing the number of columns into a separate variable for ease of access, and I can remove the semicolon. Now what I'm doing is I'm trying to run a binary search while the right pointer is greater than equal to left pointer. Because if right pointer is less than left pointer, it means we have already gone through every element in the array and we have not found our answer. We have not found our target. So now what we are doing is we are taking the middle element. What we are doing is L plus R plus 1 divided by 2, and then we have the I, that means row. I can simply write it as row. Row is basically middle divided by columns, as we saw. Then the column will be middle remainder cols, that is middle modulo cols, as we discussed here on this point. Row is division and column is modulus or remainder. Now what I'm doing is I'm simply accessing the element of that number or of that index, and I'm seeing if it is equals to target, we can simply return true. Then what I'm doing, I'm checking if this middle, okay, is actually greater than the target. Then what we have to do is we have to simply do mid minus 1. Otherwise, it simply means that the target is less than the given middle element. So we can simply change the position of left pointer to mid plus 1. And if nothing works at the end of the day, if we don't find anything, we simply return false. So yes, it's not guaranteed that we will find an answer. We can actually return false here. Now, if we run this thing, directly submit it, you can see it works just fine. So that is how you solve the LeetCode 74, that is search a 2D matrix. If you have some question that you would like me to explain, just comment.